Good morning, afternoon, or evening. How y'all doing today? Welcome back to Moral's Math Corner. Today we're going to be reviewing exponents. So let's get right to it. Let's first start with a definition of exponents. Exponents are a way to represent repeated multiplication. Repeated multiplication. And the base of a number is multiplied by itself a certain number of times indicated by the quote-unquote exponent. Let's explain that further. As you can see, the base is the largest number you're going to have there. The exponent is the little number on the top right. And this exponent or power, tells the reader how many times to multiply the base times itself. So in this particular example, 2 to the third power means that I'm going to multiply 2 times itself 1, 2, 3 times. And 2 times 2 times 2 is 8. And there you have it. That's what an exponent or power does. As far as reading exponents, always read the exponents as follows. Start with the base to the blank power. For example, if I have 3 as the base and an exponent of 4, it would be read as 3 to the 4th power. Or you could say 3 raised to the 4th power. There are a couple cool exceptions. When you have a power of 2, it's read as squared. And when you have a power of 3, it's read as cubed. For example, 4 to the 2nd power can really be read as 4 squared. And 8 to the 3rd can really be read as 8 cubed. All right, let's talk about working with exponents, just the basics. And before we do that, I want to talk to you about the invisible exponent. When an expression doesn't have a visible exponent, the exponent is 1. So for example, x really equals x to the 1st power. 2 really equals 2 to the 1st power. If I have the expression 2 times x, this is really 2 to the 1st power times x to the 1st power. So don't forget about that invisible exponent of 1 when you don't see an exponent. As far as evaluating exponents, let's go over it. 3 to the 4th power simply means 3 times 3 times 3 times 3 because it is repeated multiplication, so that would be 81. Now, negative 3 to the 2nd power, but if you notice, you have the negative 3 inside of the parentheses. Whenever you have exponents, exponents are going to affect anything to its immediate left or everything inside of the exponent, inside of the parentheses. So in parentheses, negative 3 squared will equal negative 3 times negative 3, which equals positive 9. If I have a fraction raised to a power, it's the same exact concept. It's 1/2 to the 3rd power, or 1/2 cubed is 1/2 times 1/2 times 1/2, which equals 1/8. If I have a decimal raised to the 2nd power, don't let that scare you. That's just 0.2 squared. So that's just 0.2 times 0.2, which is going to equal 0.04. If I have negative 3 squared, be very careful here. Please note that the power of 2 is affecting the 3, not the negative 1 here. That's right, that's an invisible negative 1 that's being multiplied to this 3 that's being squared. So that's going to equal negative 9. Check out negative 3 to the 3rd power. Again, this power of 3 is affecting this base of 3, not the negative 1 here. That's a negative 1 times 3 times 3 times 3. So that's going to equal negative 27. Negative times 3 to the 4th power. Please always remember that that negative is a negative 1 being multiplied to 3 times 3 times 3 times 3. So that would be negative 81. And this is a very tricky one as well. A lot of people are going to multiply the negatives here first, and that's wrong. You have to follow order of operations. So the exponents go first. And this power of 4 is affecting everything inside of the parentheses. So this negative is our friendly -1 being multiplied to -3 times a -3 times a -3 times a -3, because it's -3 to the 4th power. So whenever you're multiplying an odd number of negatives, the answer is going to be negative as well. So that's going to be -81. When you're multiplying an even number of negatives, the answer will be positive. And last but not least, just a quick little review of evaluating expressions with variables. You evaluate an algebraic expression by replacing each given variable with a corresponding given number for that particular variable. Then simplify the expression using the order of operations. So let's find the value of each expression if I go ahead and use x equals 5 and y equals 2. So I have x squared, and x, we're going to go ahead and use the value of 5. So I'm going to have 5 squared, always keep it in parentheses, plus 5 minus 12 divided by 2 squared. Okay. So I have 5 squared, which is 25, plus 5 minus 12 divided by 4. I'm following the order of operations. Now I'm going to go ahead and say 25 plus 5 minus 12 divided by 4 is 3. Again, order of operations. And then I have 25 plus 5 is 30 minus 3 equals 27. Following order of operations, please excuse my dear Aunt Sally. If I go ahead and continue here to the next one, I have 3x minus y squared. So I have 3 times parentheses 5 minus y, which is 2 squared. 3 times 5 is 15, minus 2 squared is 4, and that's going to go ahead and give me 11. All right. Hopefully that's helpful, and that rings a bell. Let's go ahead and put that over there. All right. How about this? Find the value of xy squared for x equals -5 and y equals 2. Let's first investigate this xy squared. Please remember that the power of 2 here is only affecting the y because it's not in parentheses. So I have x, which is -5, times 2 squared. So following the order of operations, that's going to give me -5 times 4, which is -20. Now, let's find the value of xy squared. Please note now that this power of 2 is going to affect everything here, everything inside. So, inside of my parentheses, I have a -5 times 2 squared. Following the order of operations, -5 times 2 is -10 inside the parentheses. -10 squared is -10 times -10, which as we know is 100. And those are the nuts and bolts of exponents. Hope you learned a lot. Thanks for watching, and come back anytime. Take care now. Have a good day.